Okay, so we're going to look at turning recurring decimals into fractions, expressing surds and also negative powers as fractions as well. So we're going to start by expressing 0.435 recurring, that's a 3 and a 5 recurring as a fraction. And just remember the recurring is shown by the 2 dots above the numbers. So the first thing I do is I name that fraction, that recurring decimal, x. So that's x equals 0.435 recurring. Now because it's got 2 recurring elements, I'm going to multiply it by 100. Now remember, I multiply it because I want to get rid of the recurring elements. So if it was 1 recurring element, I multiply by 10, 2, 100. If it's 3, I'd multiply by 1000. So 100x equals 43.535 recurring. The next part then is to do 100x, take away x, which of course equals 43.535 recurring, take away 0.4, 3 and 5 recurring. And that gives me 99x, because 100x take away x is 99x, equals, well, the recurring elements eliminate themselves, which leaves me with 43.1. Now I've got a linear equation, so I solve that, and to get rid of multiply by 99, I divide by 99, which gives me x equals 43.1 over 99. Now, we don't like to see decimals in our fractions, so I'm going to multiply the top and the bottom by 10, and that's to get rid of that decimal point, which leaves me with x equals 431 over 990. Now, looking at expressing 100 to the power of minus half as a fraction, we should remember that to get rid of a negative indice, a negative power, we flip it, so we find a reciprocal, which is 1 over 100 to the power of half. And it's root down, power up, which means that we've got a square root, so it's 1 over the square root of 100, which is of course 1 over 10. And looking at the last part here, given that f equals the square root of 2, g equals the square root of 5, and h equals the square root of 10, find in its simplest form fg over h. So these questions now are going to test both our substitution and also our manipulation of surds. So fg, well, f is square root of 2, so I have the square root of 2 times g, which is the square root of 5, over the square root of h, which is the square root of 10. Now if I just had 2 times 5, that would be 10. So the square root of 2 times the square root of 5 is the square root of 10. So the square root of 10 over the square root of 10. And we should know that anything divided by itself leaves us with just 1. Looking at the next part of this question then, we've got fg plus h. Again, we know that f is the square root of 2, so we've got the square root of 2 times g, which is the square root of 5, plus h, which is the square root of 10. Now we've just done square root of 2 times the square root of 5, and we said that was equal to the square root of 10. So you've got the square root of 10 plus the square root of 10, and that's just easier saying the square root of 2 square root of 10. And finally fh, well f is the square root of 2 times h, square root of 10. That's the same as the square root of 20. But we can break 20 up into a square number, which would enable us to take it out of the square root. So we can also show the square root of 20 as the square root of 4 times 5. And as we know, 4 is a squared number. So the square root of 4 is 2. 5 is prime, so it's 2 square root of 5.